Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 71. Lesson number 71, we are in the process of learning how to multiply algebraic expression. Day number 71. We're going to go for 5 more days, 71, 72, 73, 74, and 75. In these 5 days, what we're going to do is we're going to multiply two algebraic, very simple linear expressions, and as a result of that multiplication of the two simple linear expressions, what we will find, the result is what is known as a quadratic equation. Let's take a look at it. We are asked to multiply together x plus 3 and x plus 7. X plus 3 and x plus 7. This is an algebraic expression. X plus 3 is an algebraic expression. It has two terms, x and 3. This is an algebraic expression, even though they are very simple, but they are algebraic expressions, and we are asked to multiply these two expressions. That's what we're doing right now. So let's do it then. And what we'll find at the end, as I told you before, is what is known as a quadratic equation, and we'll see what we'll do with it in a second. Okay, so here's how it goes. You multiply x times x gives you x squared, then x times 7 is going to give you 7x, and then three times x, which is going to give us 3x, and then 3 times 7 gives us 21. Here I did not have to say positive or negative. I didn't have to worry about it. We didn't have to worry about it because everything is positive. But of course we have to be careful. Positive times positive is positive, and so forth. Anyway, that's it. Now we have to combine the like terms. That's what we did. That's what we did in the first. That's what we did in the day 21 through 50. We learned how to add and subtract algebraic expressions, where we learn how to combine like terms. Here, the like terms are these two, 7x and 3x. We have to combine them. And when we combine them, we get this. X squared plus 10x plus 21. Voila. Now, if we were to set this expression to 0, if we were to set this expression equal to 0, what we will have is what is known as a quadratic equation in its standard form. Let's write all of that down, what I just said. I'm going to erase this part, we no longer need it. I should have written it inside out so I had a room to write here, but I don't. Let's squeeze it in here. If we were to set this expression equal to 0, now when I say this expression, I'm talking about this expression right here, or this expression for that matter. If we were to set this expression equal to 0, then what we will have is what is known as a quadratic equation in its standard form. But this is known as quadratic equation if we were to set this equal to 0. There you go. Now it's a quadratic equation. Before it wasn't an equation. This is not an equation, it's an expression, because an equation, in order to qualify as an equation, has to have equal sign. It has to equal to something. And if we were to set it equal to 0, not 5 or 3 or 7, set it equal to 0, then it becomes what is known as a quadratic equation. I'm going to read it to you here one more time. It says, if we were to set this expression right here, 7x squared plus 10x plus 21, this expression right here, if we were to set this expression equal to 0, which is what we just did here, then what will arise, what we will have is what is known as a quadratic equation. This is a quadratic equation in its standard form. In its standard form. Let's talk about what standard form means. The standard form of a quadratic equation looks like this. Ax squared, let's put it in a different color. Ax squared plus bx plus c equals 0. Now this a, b and c that you see there, these are coefficient of these terms. A is the coefficient of a squared, b is the coefficient of x, and c is what is known as constant. Let's see what the values are here. In this expression right here, our a equals 1. That's our a. Our b equals 10. And our c equals 21. And it is in standard form. Now I'm going to write the same equation. But not in standard form. Watch here. X squared plus 10x plus 21 equals 0 is in standard form. I'm going to write the same equation, even though the equation is going to be the same. Nothing has changed. It's going to be the same information. It's going to have the same values of x, which will satisfy this equation. And we'll talk about that in a second, what it means to satisfy an equation. Well, everything is going to be the same, but just by the virtue of writing it differently, it will no longer qualify as in its standard form. Watch here. If you were to write this as x squared plus 10x equals negative 21, in other words, bring the 21 to the other side. In other words, subtract 21 from both sides, it becomes negative 21 here. This is no longer standard form. If you were to write the same thing here as 10x plus 21 equals 10x plus 21 equals negative x squared, it still is the same equation, but it's not in the standard form. If you were to write this as x squared plus 21 equals negative 10x, it's no longer in standard form. Only this one is in standard form. The standard form means on this side we have to have a 0. And the term with the second power has to go first, term with the first power goes next, and then the constant. This is known as standard form. Now let's talk about what values of x will satisfy this equation. I need the room, so I'm going to erase all of this here. But for our record, let's put this here so we know what we had originally. X plus 3, x plus 7. Let me look at the time in the back of the clock, in the back of the camera, because I want to keep it within a certain period, and that will determine as to how much in depth I want to get into this thing, because we can go on for 2 hours on this subject. Okay, just give me a second. I'll be right back in 10 seconds. I'm still here, just looking in the back. I am 9 minutes into it, so I'm going to call it a day here. This is it. In the next video that we make, as I said, we're going to go on for 5 days. We will cover little by little, but anyway, we wanted to multiply these two expressions. We did that, and we arrived at this thing. I'm going to erase all of this thing because these are all non-standard form. Let's erase all of this thing. When we multiply these two expressions, what we get is this here. One doesn't actually write 1 on top of x, because if it's just x, we know that it's raised to the first power. You don't have to put it there. And I also know that it's just 1x. If you just write a, I know it's 1a. And I also know that it's raised to the first power, because had it been raised to something other than the first power, you would have put it there. 1 is the default. So when you multiply two expressions such as these, two linear expressions, simple linear expressions as you see here. Linear means x is raised to the first power. What arises as a result of the multiplication of these two expressions is something like this. An expression with the second power. The second power arises from the multiplication of x times x. And what we have here is what is known as a quadratic equation in its standard form. I will see you tomorrow. I will do four more problems like these. And we're not going to go into this thing because right now we are not learning quadratic equation. Quadratic equation comes much later in the course. Because we are right now we're just learning how to multiply algebraic expression. That's all we're learning. We're learning how to multiply things. That's all. So we have done that. When you multiply these two, we get that. Okay. I will see you tomorrow. There will come a time where we're going to more in depth into this thing. We're going to learn things like quadratic formula. We're going to learn how to find the solution of this equation and factorization and all that. But that will come much later. Okay, slowly but surely we'll get there. Okay, I will see you tomorrow on day number 72.